Imagine a world with no North America, no Europe, no Asia, just one enormous landmass stretching from pole to pole, where dinosaurs hadn't yet roared, and insects the size of falcons buzzed through ancient forests. Welcome to Earth during one of its most mysterious and epic chapters. This is Pangea, the supercontinent that ruled the world. Before we explore what Earth was like during Pangea, we need to take our minds far back. Way, way back, hundreds of millions of years ago. The Earth hasn't always looked the way it does today. In fact, it hasn't even had its current shapes for the majority of its history. The 7 continents we now know, North America, South America, Europe, Africa, Asia, Australia, and Antarctica, are merely the result of a long, restless geological journey, an ancient journey of colliding plates, drifting land masses breaking, folding, and heating from within. Yep, our planet is alive, but not like you or me. It moves in slow, grinding shifts beneath our feet. And about 335 million years ago, after countless collisions and hundreds of millions of years of slow drift, the ultimate landmass came together. One giant supercontinent, Pangea. Let's use your imagination like a time-traveling satellite. Picture a massive jigsaw puzzle. Think the size of an entire planet. Every continent you know is a puzzle piece. Now, if you could push those pieces together, just nudge South America eastward until it kisses the curve of Africa, squeeze Europe southward, and let Antarctica snuggle up against Australia, boom, that's Pangea. It's not science fiction. Scientists have done this exact exercise using real geological data. They've matched up rock layers that align between continents' fossil records showing the same species, found across oceans' mountain chains perfectly, aligned across now separate land masses. These matches are like cosmic breadcrumbs leading us back to when the world was one. So, what did the map look like during the time of Pangea? Let's break it down. Pangea mostly stretched along the equator, meaning it enjoyed warm temperatures across most of its land surface. The majority of Earth's landmass was clustered in one huge slab, while the vast ocean around it was called Panthalassa. Greenland? Australia? Antarctica? They were there, but part of different chunks near the southern end. The enormous inland areas were isolated from the coast, creating vast deserts and harsh climates. It's important to understand that with so much land in one place, and the ocean taking up the rest, it totally flipped our modern idea of weather patterns, sea levels, biodiversity, and energy distribution. Think of it this way. Today, wind and moisture travel thousands of miles across oceans, bringing rain and balancing temperatures. But Pangea? It had gigantic inland areas that got none of that moisture. It was a recipe for wild weather, extreme climates, and mass extinction events. Now, let's get just a little technical, but still fun. Why do continents move at all? Meet plate tectonics. The Earth's crust, the solid outer layer we live on, isn't a single piece. It's made up of multiple tectonic plates like giant rafts floating on the semi-liquid mantle below. These plates are constantly shifting, moving just inches per year, but over millions of years, those inches turn into oceans. About 600 million years ago, there was another supercontinent before Pangea, Rodinia. And before that, even more. Earth goes through a supercontinent cycle every 300–500 million years. So Pangea wasn't the first, and it won't be the last. Pangea began forming roughly 335 million years ago during the late Paleozoic era, and it lasted well into the early Mesozoic era, starting to break apart around 175 million years ago. That's 160 million years of Earth's history, dominated by a single united landmass. To give perspective, humans have only existed for 200,000 years. Dinosaurs? About 230 million years ago. So for much of Pangea's existence, life was simpler biologically, but the environment was wildly hostile, changing, and full of precursors to many of the life forms we know today. When you hear supercontinent, You might imagine a paradise of green landscapes, rolling hills, rivers, maybe something out of Avatar or Middle-earth. But reality? Much harsher than that. The interior of Pangea, especially far from the coasts, was hot, dry, and mostly desert. Without oceans to moderate the temperature and bring in moisture, these inland regions became massive arid zones, likely peppered with seasonal rivers and oases. Think the Sahara Desert, but stretching from modern Arizona to Central Asia. Plants adapted to this world, thick-skinned, drought-resistant, and hardy. But only in certain regions could lush forests exist, mostly along coasts. Of course, a continent is only as cool as the creatures walking all over it, right? We'll dive deep into life in Section 2, but a quick teaser. Pangea set the stage for the emergence of early reptiles, giant insects, and even the ancestors of dinosaurs. It was like an incubator, a single land path for animal migration across the world. No oceans between North America and Africa meant creatures could just walk. Despite all this ancient beauty, life on Pangea wasn't easy. Earth trembled regularly. The tectonic pressure underneath the supercontinent had nowhere to go, so when it snapped hard. Giant earthquakes shook the land. Volcanoes erupted across massive fault lines. These weren't just local disasters. These were events that could change the climate for millions of years, and it gets worse. Because just before the breakup of Pangea, Earth witnessed the biggest extinction in our history. But more on that in Chapter 6. Time travel isn't real, yet. So how do we even know about Pangea? Let's credit a brilliant German meteorologist, Alfred Wegener. In 1912, he proposed the idea of continental drift, suggesting that all continents were once part of a larger supercontinent. At the time, the idea was ridiculed. It wasn't until the 1960s, decades after his death, that scientists found hard evidence. Thanks to seafloor mapping and geological surveys, Wegener was finally vindicated. One man had visualized the movements of immense land masses with nothing but rock samples, fossils, and his imagination. A century before Google Earth, Pangea isn't just some boring ancient trivia, it's our origin story. The shapes of continents today, born from Pangea's breakup, climate problems we face today, influenced by millions of years of plate movement, earthquakes in California, volcanoes in Iceland, all part of the same tectonic legacy. By understanding Pangea, we understand how raw, powerful, and ever-changing our planet is. And guess what? We're due for another supercontinent. But that's a story for another chapter. Let's rewind back to roughly 335 million years ago, just as Pangea was forming. What was really epic about this time wasn't just the merging of continents. It was the evolution of life in totally new directions. Until this point, life had mostly stuck close to water. Oceans were the powerhouses of biodiversity, and land was home to moss, lichen, and not much else. But as Pangea formed and climates shifted, life began a bold new experiment, colonizing dry land. This marked a massive turning point in Earth's history. Even before the dinosaurs showed up, Earth was getting green, but not with flowers or grass. Those didn't exist yet. The plants of Pangea were strange to us today, but wildly successful in their time. Plant superstars of Pangea, lycopods, giant club mosses, could grow over 100 feet tall, looked like palm trees, but were actually ancient mosses. Ferns and tree ferns dominated the swampy coastal areas, reproduced via spores. Not seeds, horsetails. Equisetum, grew up to 30 feet, had rigid, segmented stems and loved moist ground seed ferns. Extinct group, not true ferns. Early experiment in plant reproduction, some of the first plants with seeds. Glossopteris. A Pangea-wide plant. Its fossils were found from South America to Antarctica, proof that all these lands were once joined. Now it gets weird, because during the early stages of Pangea, Earth's atmosphere had more oxygen than today, as much as 35% compared to today's 21%. And that did something very cool, or terrifying. depending on how you feel about bugs. It gave us insects the size of small dogs, giant insect highlights Meganeura, a dragonfly with a wingspan of 2.5 feet, Arthroplura, a millipede longer than a grown man, up to 8.5 feet, Pulmonoscorpius, a scorpion the size of a house cat that roamed the land. These creatures didn't just crawl, they dominated ecosystems. Meganeura ruled the skies before birds and pterosaurs. Why were they so big? More oxygen, times fewer predators, bug paradise. By the late Carboniferous and early Permian periods, amphibians started giving way to something new: reptiles. Amphibians were great, but they had one weakness: they still needed water to survive. Reptiles? Game changers. They laid amniotic eggs, which meant they could live far from water for the first time in evolutionary history. Early reptiles: Mesosaurus, a freshwater reptile that looked like a small alligator, found in both Africa and South America, again proof of Pangea. Dimetrodon, not a dinosaur but a sail-backed mammal-like reptile. Edaphosaurus, weird-looking ancestors to mammals with massive sail spines and herbivorous diets. These reptiles spread quickly across Pangea because there were no geographic barriers to migration. If it lived in what is now Argentina, it could walk to Ethiopia. That's how open this land was. We often think of continents as diverse ecosystems, from deserts to forests to frozen tundras. But in Pangea, most of the continent was inland, hot and dry, far from ocean moisture. This meant much of the interior was desert or dry scrubland. The biodiversity hotspots were coasts, where lush forests existed, rivers and lakes, holding amphibians, insects and early fish, shady forest edges. Great for plant growth and lurking predators. You might be wondering, how do we know what lived on Pangea? Thanks to fossils spread across modern continents, layers of sedimentary rock that match across oceans, carbon dating of preserved trees and swamp layers, paleobotany, the study of ancient plants through fossilized leaves, wood and spores in Antarctica, which was once green and covered in forests. Scientists have even found imprints of ancient tree ferns, buried under glaciers. Here's a cool twist. Pangea predates the age of dinosaurs by tens of millions of years, but what came before them might be even more bizarre. Pre-dino rock stars, Gorgonopsids, saber-toothed proto-mammals with powerful jaws, Therapsids, the weird line between reptiles and mammals, reptiliomorphs, amphibious lumbering beasts that carried traits of modern tetrapods. These creatures were uniquely adapted to Pangea's extremes: droughts, flooding, wild temperature swings, and they laid the groundwork for what would come next. The Age of Dinosaurs. The interior of Pangea faced extreme seasonal heat and cold, hardly any rainfall, frequent volcanic activity. Living in Pangea wasn't just unusual. It was a constant battle to survive. The creatures that thrived here were tough, adaptable, built for extremes. This crucible of survival shaped life into smarter, stronger, and more resilient forms. One of the most fascinating things about Pangea, it allowed mass migration of life on a global scale. Birds didn't exist yet, but reptiles, mammals to be, and insects could travel thousands of miles uninterrupted. The same creature could evolve across what would eventually become entire continents, and that's how paleontologists today can find identical fossils across different modern continents. What happened to these ancient plants and animals? As climate patterns shifted and Pangea continued developing, many species died out. Others evolved into entirely new groups. The Earth prepared for its next major chapter, the Mesozoic era, the age of dinosaurs, but Pangea laid the groundwork. It was a stage, a laboratory, a pressure cooker for evolution, and its legacy continues in the bodies of everything on Earth today, including us. At first glance, a single continent might seem peaceful, maybe even stable: no border collisions, no continental crushes, no tectonic drama, right? Wrong. Pangea didn't relieve Earth's stress, It amplified it. Why? Because Earth's inner layers are constantly moving, molten rock churning under our feet, trying to escape from the planet's pressurized core. Normally, tectonic plates relieve this stress by slipping and sliding at their edges. But when everything's connected, as in Pangea, there are fewer edges, and nowhere for that massive buildup to go. That means the pressure builds and builds until it explodes. Q. Massive rift zones, megaquakes, and the largest volcanic events in Earth's history, modern earthquakes, like the 2011 Japan quake or the San Andreas tremors, are devastating. But on Pangea, we're talking about continent-wide fault zones, where land cracked open for hundreds of miles. Ancient valleys formed that still exist today. Ocean basins began forming inside the supercontinent. One major hotspot, the Central Atlantic Magmatic Province, or Camp. Located where North America, South America, and Africa were once fused. It's one of the largest continental volcanic events in history, and it's intimately connected to both earthquakes and mass extinction. Don't worry, we're building up to that. In a later section, the massive movement carved huge rift zones, setting the stage for the Atlantic Ocean to be born millions of years later. These weren't just local cracks. They're what we now call continental rifts, the early signs that Pangea would eventually tear itself apart. Imagine standing on a cliff in Pangea. The sky darkens. The air smells like sulfur. Then boom, the earth vomits fire. But this isn't a one-time event. It goes on for thousands of years. These were flood basalt eruptions, massive, lava-spewing events that spread across entire regions. The Great Eruption Zones, Siberian traps, toward the end of Pangea's lifespan, erupted for over 1 million years, released trillions of tons of lava and carbon gases, caused global warming. Ocean acidification and mass extinction. Karoo-Ferrar, modern-day South Africa, Antarctica, covered over 1 million square kilometers, enough lava to bury most of the U.S. under a mile of rock camp. Central Atlantic Magmatic Province, created when Pangea began breaking, may have contributed to one of the greatest die-offs on record. Volcanoes weren't the only threat. Pangea's sheer size caused atmospheric chaos. Why? With one supercontinent, air could travel thousands of miles before hitting obstacles. Moisture from the ocean had a long way to go inland, often never making it as a result. The center of Pangea became a superheated, dry desert, while the coasts were humid and storm-lashed. This imbalance triggered megastorms far larger than hurricanes we know today, flash droughts, followed by sudden, unrelenting floods, dust storms that could bury entire ecosystems. Temperature extremes from sweltering day heat to freezing nights. Essentially, an unstable, breathing, destructive weather engine. Pangea, planet of extremes. Hotter than Sahara by day, colder than the Arctic by night. Stormier than Jupiter on the coasts when you combine volcanic eruptions, earthquakes, superstorms, dying ecosystems. You get what scientists call a geological cascade event, a disaster so big it triggers other disasters. Volcanic ash lowers global temperatures. Ocean circulation stops. Methane and CO2 rise. Ocean turns acidic. Mass die-offs begin again. This is foreshadowing the Permian-Triassic extinction coming in Section 6. Here's the craziest part. Despite everything, life found a way. Plants evolved to survive ashfalls and droughts. Reptiles grew more adaptable, tougher. Meaner burrowing species appeared, hiding underground during the worst eruptions or storms. Some amphibians developed traits that would lead to mammalian ancestors. The stress didn't just destroy, it shaped evolution itself. How do modern scientists know about all these prehistoric disasters? Tools of the trade. Volcanic layers in continental rock. Lava flows over 100,000 years old. Shock quartz. Minerals that only form under earthquake-level distortion. Ash bed layers, found across continents. Carbon isotope changes showing ocean die-offs, temperature drops, and acid spikes. Basically, Earth recorded its own trauma, like scars across its skin, and we've learned to read them. Want to know how crazy this was? If just one of Pangea's eruptions happened today at the same scale, global aviation would stop for years. Temperatures could drop by plus 10 degrees Celsius worldwide. Crop failure would lead to famine. Millions, if not billions, would be affected, and natural disaster recovery would take decades. But in Pangea's world, that chaos was normal. Think this was all long gone. Same processes still happen today. Yellowstone, supervolcano hotspot. East African rift, a new tectonic break forming earthquakes in Turkey. Chile, California, deep sea volcanoes shaping new land right now. Pangea may be gone, but the Earth never stopped moving. We're still riding this wild machine. All this heat, pressure, and fire, it adds up. The final centuries of Pangea's volcanic chapter led directly into a mass extinction event so bad, it wiped out over 90% of all life on Earth. That story is up next in Section 6. But here's what to remember. Pangea was a time of creation and catastrophe. It gave rise to new ecosystems but raised others with fury. It wasn't just one land. It was a land under siege by the forces of the planet itself. Let's kick off with some simple Earth science. Our modern world is made up of 7 continents, spaced out, surrounded by oceans and broken up by mountain ranges. This gives us a good balance: sunlight, moisture, atmospheric movement, ocean currents. It's a complex global system that helps regulate climate, but when everything gets squished together into one tectonic continent, like during the days of Pangea, things go off the rails. There's less coastline relative to landmass. Inland areas become cut off from ocean moisture. Ocean currents hit dead ends, and wind patterns become supersized and unstable. In short, Pangea, calm climate chaos. Imagine North America, South America, Africa, and Asia all welded together. Now remove the oceans between them. What you're left with is a weather system with no breaks. The interior of Pangea was a dry, blistering wasteland for much of its life. Stretch that over what we now call the continental U.S., the Sahara, the Middle East, China, and put it all under relentless sun. No seas. No ocean breeze, just sand, wind, heat, dust. Climate models suggest temperature swings of 50, 60 degrees, 30 degrees C between day and night. There were entire regions of inland Pangea that likely saw no rain for years, mega droughts that lasted decades, dust storms so massive they could blanket regions the size of modern countries. The center of Pangea may have reached summertime temperatures of 120 degrees, 49 or higher, without the greenhouse gases we worry about today. The biggest climate challenge Pangea faced was simple. How do you get water inland? Rain clouds are mostly fueled by evaporation over oceans, but if the coasts are hundreds or thousands of miles away, then coastal storms can't cross into the interior before dumping their water. As a result, the coasts were lush and green, inland regions were arid and harsh. Rivers and lakes occasionally formed, mostly due to seasonal melting, and highland areas temporary flooding from violent storms, but they were unpredictable and short-lived. Imagine a continent where rivers dry up midstream, where forests become deserts in a generation, and where life clings to the coastlines because inland, even survival is a gamble. The skies over Pangea were unlike anything we'd recognize today. Depending on the era, the atmosphere had wildly differing compositions. Higher oxygen content, a 30–35% during the late Carboniferous, CO2 levels swinging between highs and lows due to volcanic activity, thick clouds of ash, and dust during volcanic periods. These atmospheric variations caused frequent acid rain, widespread dimming of sunlight, volcanic winters, gigantic lightning storms, seasonal flash freezes. You could literally leave one region of Pangea, walk a few hundred miles, and enter an entirely different climate zone. If you love extreme weather, buckle up. The massive size of Pangea meant storms weren't just bigger, they were monumentally destructive. Meteorologists today study hurricane systems like Katrina or Typhoon Haiyan. But on a Pangean scale, those were babies. The ingredients for ancient superstorms: hot, dry air from the interior moist. Cool air from narrow coastal zones, volcanic ash or dust to agitate the atmosphere. Sudden violent pressure drops, the outcome: thunderstorms larger than modern Europe, supercell tornado clusters covering regions the size of the Amazon, durations lasting for days, not hours. Aftermaths that could reset evolution in a region. Picture a storm where lightning strikes millions of times per hour, where rain turns to hail the size of fists, where entire herds of prehistoric animals disappear into flash floods. That wasn't just possible, it was likely. Even though Pangea was one giant piece of land, it wasn't just one single climate. Geography and elevation matters. A few Pangean regions: Northwest Pangea, future North America; semi-desert with seasonal monsoons, equatorial belt, Africa plus South America; lush, tropical rainforest near the ocean, southern Pangea, Gondwana; semi-arid plateaus, cooler forests, highland zones, modern Europe and parts of Asia, more temperate with rainfall. So if you were a time-traveling tourist, want tropical jungle? Head closer to the equator or coast, prefer cool, foggy landscapes. Hike into the higher elevations in the south, brave enough for sand dunes and heat mirages? Go west, show an animated topography of Pangea, with current-day country outlines faintly overlaid, demonstrating how desert and forest zones overlay modern regions. You already met the reptiles, bugs, and early mammals of Pangea in earlier sections. But climate shaped evolution more than almost anything else. Deserts led animals to become smaller. Tougher nocturnal forest zones allowed some species to grow. Gigantic temperature extremes pushed the early development of warm-blooded creatures. Drought air cold adaptation created a long evolutionary testing ground. Even plant life adapted. Trees with thick bark to survive ash falls, ferns evolving to spread spores without water, deep-rooted plants forming early versions of modern grasses, though still millions of years undecided. Pangea wasn't just hot and dusty. It had warm periods caused by CO2-spitting volcanoes, and cold sunblocked decades caused by the very same eruptions. This caused species whiplash, adapt or die, entire forests to vanish between generations, mass migrations of animals chasing livable regions, massive die-offs in freshwater ecosystems trapped between climate swings. It was the earliest version of rapid climate change, and it left permanent scars in the fossil record. Scientists have spent centuries piecing together these details, thanks to clues in sediment layers, coal beds, glacial striations, fossilized forests in Antarctica, evaporate deposits in deserts. Each one tells a story: where water was, where it vanished, and how life chased it. In some rocks, mud layers alternate with dust, showing seasons of rain, then years of dry. It's like reading ancient climate journals, written in stone. Here's the big question your viewers may be asking. If this all happened 200+ million years ago, why should I care now? Because the climate events we face today, heat, storms, extinction, rising CO2, already happened before, and Earth responded with violence. Mass extinction reshaped coastlines, and new dominant species. Understanding ancient climate history helps us predict Earth's future. Before we go full apocalypse, let's define our terms. A mass extinction is a rapid, global decrease in biodiversity across multiple ecosystems: land, sea, freshwater, air, often caused by multiple overlapping disasters. Earth has had 5 major extinction events: Ordovician, Silurian, late Devonian, Permian, Triassic, the Great Dying, Triassic, Jurassic, Cretaceous, Paleogene, goodbye dinosaurs. But out of all of them, the Permian Triassic was the worst. By far, let the numbers speak. 96% of marine species extinct, 70% of land species gone, entire groups of animals vanished forever, forests collapsed for millions of years. This was the closest Earth has ever come to becoming a lifeless planet. Let's time travel back about 252 million years ago. near the end of Pangea's existence. Life was thriving across the supercontinent. Amphibians were gigantic and diverse, vast forests stretched across the coasts. Early reptiles were on the rise. Marine life included coral reefs, trilobites, and ammonites. Then, everything started to collapse. The culprit? A perfect storm of planet-wide disasters, centered around one of the largest volcanic events in Earth's history. A region in northern Pangea, today known as Siberia, erupted violently. But this wasn't a single explosion. It was millions of years of continual lava flows releasing CO2, methane, and sulfur dioxide, enough lava to cover the entire United States in a mile-deep layer. So much gas, it rewrote the atmosphere. Results: global warming of up to 10 degrees and 18 degrees. Acid rain destroyed land vegetation. Oceans became warm, stagnant, and toxic. Methane released from seafloor hydrates, turbocharging greenhouse effects. It wasn't one death blow. It was a chain of suffocating, choking, boiling disasters that spread across millions of square miles. The ocean suffered the most during the Great Dying. Normally, ocean currents circulate cold, oxygen-rich water from poles to equator and back. But during the Permian-Triassic event, that circulation stopped. CO2 levels skyrocketed, temperature rose. Oceans became hotter, acidic oxygen depleted, full of hydrogen sulfide gas, deadly to nearly all marine life. Entire food chains collapsed. Plankton died. Corals died. Fish species died. Reef predators and filter feeders vanished forever. Marine fossils from this time show layers of extinction, not just one event, but waves of ecological collapse. On land, things weren't any better. Skies filled with volcanic ash, blocked sunlight, stunted plants, acid rain, poisoned soils, rising temperatures, intense droughts common. Effects: forests burned or dried. Out insects disappeared in massive numbers. Food chains fell apart. Habitat loss led to widespread animal migrations and extinctions. Carbon-rich coal forests in the northern Pangea region vanished almost entirely. If you were alive back then, you'd see mass graves, collapsing ecosystems, and a world that looked more like a wasteland than a planet you could survive on. Gone forever. Trilobites. Millions of years of dominance ended. Blastoids. Brachiopods, most soft-bodied corals. Extinct gorgonopsids. Massive saber-toothed predators of the Permian. Many early amphibians. Giant insects. And seed ferns barely survived. A few therapsids, mammal ancestors. Some reptiles in the Archosaur group, which would later evolve into dinosaurs. A few adaptable early plants in oceans. Bivalves. Sharks, early squid-like cephalopods. Only 1 in 10 species made it through. Those survivors weren't lucky. They were tough, small, adaptable, and often lived in water, burrows, or shaded areas. After the Permian extinction, Earth didn't bounce back right away. In fact, it entered what scientists call an ecosystem gap, a time when nothing dominated the planet. Forests took 5 to 10 million years to regrow. In some places, biodiversity levels remained below pre-extinction numbers for over 100 million years. Entire landscapes were covered in barren rock and dust. This was an emptier Earth, a lonely one starting over again. Evidence of the Great Dying can be found all over the world. Layers of black shale, oxygen-depleted oceans, sharp drops in carbon isotopes, mass plant and animal deaths, iridium and ash layers from volcanic activity, fossil records showing extinction gaps, a sudden lack of life, basalt layers in Siberia measuring over 2 kilometers thick. Even Antarctica, once part of lush southern Pangea, holds silent fossils from this time: trees, insects, and amphibians frozen in stone. Let's imagine you're a primitive animal, a reptile, fish, or burrowing mammal-like creature. Suddenly, strange clouds appear. The ground trembles with each passing week. Rain becomes acid. Food vanishes. Waters heat up and stink of decay, you either adapt, hide underground, migrate, and hope to find livable conditions, or die. The entire world becomes a survival gauntlet. Even the resilient ones struggle. But from this crucible, new life will eventually emerge. Here's the light in the darkness. The extinction clears a path for the future. In the aftermath, new species begin to evolve, surviving. Reptiles lay the groundwork for dinosaurs. Tiny therapsids, our ancestors, survive long enough to eventually evolve into mammals. Marine life recovers with new reefs, fish, and early modern predators. Without the great dying, dinosaurs might never have taken over. And without the dinosaurs' reign ending, mammals may never have had their shot either. This extinction, as awful as it was, became the great plot twist in Earth's evolution. Here's the connection that brings it all full circle for your audience. Scientists say we may be entering Earth's sixth mass extinction today. Why? Human-driven climate change, ocean warming and acidification, deforestation and habitat destruction, massive extinction rates of plants, insects, and animals. Understanding the Permian-Triassic extinction gives us a glimpse into what unbalanced Earth systems look like, and how devastating the consequences can be if they're pushed too far. The Great Dying was Earth's harshest lesson. A warning written in ash, stone, bones, and silence. Life nearly ended. But from the dirt and disaster, it began again. Next up, we uncover the beginning of Earth's most iconic breakup, when Pangea finally starts tearing itself apart. Join us in Section 6, the slow break, when Pangea tore apart. Let's start around 200 million years ago. During the early Jurassic period, Pangea had just survived the Great Dying. Life was clawing its way back. Reptiles had evolved into early dinosaurs and new forests were rising. But the very ground beneath those forests was restless. Deep in the Earth's mantle, superheated material was rising toward the crust. The pressure had built up for tens of millions of years. The Earth's surface, locked in one supercontinent without tectonic relief, couldn't hold it back forever, and then it began to split. Continental rift zones formed. The first cracks didn't look like explosions. They were slow, massive, violent fractures. Rift valleys opened, fault lines zigzagged across the continent, magma pushed up from below, forming massive volcano chains. Entire ecosystems were split apart slowly over millions of years. Pangea's slow break wasn't just a geological event, it was a biological separation, an ecological reboot, and the beginning of our planet's fractured identity. Key dates for the break. 200 Maya. First major rifts formed between East North America and Northwest Africa. Bitla Maya, central. Pangea splits into Laurasia, north, and Gondwana, south. 50-100. Maya. Oceans widen between continents. Maya and beyond. Modern continents take shape. One of the most dramatic triggers of Pangea's collapse. The Central Atlantic Magmatic Province, or CAMP it was. One of the largest volcanic systems in history, erupted. Over 500,000 square kilometers of land spewed billions of tons of CO2, methane, ash, and toxic gas. This event didn't just help split the land. It may have caused another mass extinction, Triassic-Jurassic, opening space for the rise of dinosaurs. The lava from CAMP still exists today, in the eastern U.S., northwestern Africa, parts of South America, under the Atlantic Ocean. It tells a story. Here is where the world began to split. You look at the cliffs in Morocco, ancient basalt fields in Brazil, the Appalachian Mountains, and you can see the scar tissue from Earth's most violent breakup. The breakup followed natural weaknesses in the Earth's crust, places where stress gathered like cracks in old glass. Step-by-step continental drift. Atlantic rift forms between North America and Africa, start of the Atlantic Ocean. South America and Africa split. Gondwana breaks apart. Antarctica drifts south. India shoots northeast. Australia begins separating. Laurasia splits later into North America and Eurasia. Each break wasn't a clean one-time event. These were intermittent fractures that stretched across tens of millions of years, with earthquakes, lava flows, and the slow dance of drifting plates. Once the crust split, magma surged upward, forming new oceanic crust, and the oceans themselves began to grow, pushing continents apart. This is how the Atlantic Ocean was born. Each year, it widened by just a few centimeters, but over millions of years, that gap becomes the massive Atlantic we know today. Tectonic plates drifted apart, pulling the Americas westward, Africa eastward, India northward, heading for a big surprise. These new oceans became climate drivers, biodiversity hotspots, and natural dividers between species that had once lived side by side. As continents moved apart, isolation began and evolution exploded. Why? Because species were now trapped in new environments. No more easy migration, no more shared ecosystems, so they adapted, mutated, and evolved into strange new forms. Examples: dinosaurs in South America became different from those in Asia. Primitive mammals in Africa evolved separately from those in Australia. Marine life in the Atlantic diverged from the Pacific. The breakup of Pangea led directly to the explosion of life variety we know today. Without the breakup, there would be no tigers in Asia, no elephants in Africa, and no marsupials in Australia. Pangea's breakup also shaped Earth's modern geography. How? When continents collide or rip apart, they form mountain ranges, rift valleys, seafloor trenches. Some examples: Himalayas, formed when India slammed into Asia, 50 Maya. Mid-Atlantic Ridge, still growing the Atlantic today. Appalachians and Scottish Highlands, originally part of Pangean mountains. The very landforms you walk on today are the reworked remnants of Pangea's collapse. Yes, you can visit the past. Here are real-world places tied directly to Pangea's fracture: the Mid-Atlantic Ridge, underwater ridge where continents are still drifting; the East African Rift Valley, a new continent in the making; the Red Sea, a baby ocean forming as Africa; and Arabia partways; the Deccan Traps, India, basalt plains from ancient eruptions during drift; Appalachians plus Atlas Mountains, pieces of one original mountain chain, now separated by the Atlantic. The Earth keeps the receipts. Believe it or not, Pangea wasn't the first supercontinent, and it won't be the last. Earth follows a supercontinent cycle. Every 400 to 600 million years, all landmasses eventually drift, collide, and merge again past supercontinents. Rodinia, Colombia, Panocha. Pangea formed 335 Maya and broke 175, 100 Maya. Future supercontinent nicknames: Pangea Proxima, Novo Pangea. Amasia scientists predict a new supercontinent could form in the next 200-300 million years. So yes, eventually Earth's land will become one again. Just imagine. One massive landmass, homogeneous species everywhere. Slower evolutionary trend. No separation of cultures, ecosystems, or weather systems. Would humans even exist? Would dinosaurs have dominated longer? Would there be less biodiversity? Maybe no Australia's marsupials at all? It's one of science's greatest what-ifs. But we know this: the breakup of Pangea created the modern world. By around 100 million years ago, Pangea was gone. In its place, vast oceans, multiple continents, isolated species, new evolutionary kingdoms. The dinosaurs ruled. New plants evolved. Ocean circulation changed climate again, and eventually, mammals would rise to inherit it all. Pangea's slow breakup took over 100 million years, but it reshaped ecosystems, climate, history, and quite literally our place on Earth. Let's start here. Pangea existed hundreds of millions of years ago. No humans, no photos, no satellites. So how is it anything more than just a theory? Because the Earth tells its story. In rocks, fossils, formations, and mountain chains. Like a detective novel, all the clues are still here. The 4 key clues of Pangea's existence. Fossil similarities. Mesosaurus, a freshwater reptile found in both South America and Africa. Glossopteris, plant, found across Africa, Antarctica, India, Australia, and South America. Lystrosaurus, found in Africa, India, and Antarctica. Rock and mineral structures. Ancient mountain chains match exactly between continents, Appalachians, and Caledonides. Coal beds in Europe and North America. Same age. Same plant fossils fit of the continents. South America's east coast fits neatly into Africa's west coast, assembled like puzzle pieces. The continents form a perfect megacontinent. Geological alignment faults and rift zones line up when continents are reconnected. Volcanic belts stretch across continents now separated by oceans. This isn't coincidence, and it's not just theory. It's stone-cold evidence laid down over millions of years and stretched across half the planet. Let's explore how Earth's mountains hold the fingerprints of Pangea. Mountain chains born from Pangea's birth. Appalachians, eastern U.S., Caledonides, Scotland and Norway, Anti-Atlas Mountains, Morocco. These all formed when Laurentia, ancient North America, collided with Gondwana, ancient Africa. Today, they're thousands of miles apart, but geologically, they're the same chain formed during Pangea's assembly. It's like Pangea's spine still supports Earth today, just in pieces. The newborn oceans from Pangea's breakup still shape today's weather patterns, oceanic biodiversity, modern trade routes, climate system drivers. The Atlantic Ocean started as a rift within Pangea, just a tiny crack. Now it's one of the major players in climate regulation and ecosystem flow. At the bottom of its deepest trenches, the Atlantic still holds lava formed during Pangea's disintegration. Pangea didn't just separate land, it separated life by creating physical barriers, oceans, deserts, mountains. It allowed species to diverge, leading to marsupials thriving in isolated Australia, unique megafauna in Africa, ancient birds in New Zealand, dinosaurs specialized by continent. Later, this led to unique humans adapting to various environments. The roots of modern biodiversity stem from Pangea's breakup. All animals today, yes, even humans, evolved from evolutionary lines that either spread or diverged during Pangea's era and after. Here are some real-world examples of places where Pangea's legacy is visible. Gibraltar and Morocco, once connected during Pangea's time, now separated by ocean, but share nearly identical geological strata too. Brazil and West Africa, fossils and ancient river systems match perfectly. Ancient rocks align across both coasts. 3. Australia and Antarctica used to share a temperate forest belt. Buried under modern glaciers, fossilized trees found beneath Antarctic tectonic activity today. Earthquakes, geysers, volcanoes isn't random. These are the echoes of Pangea's collapse, still active today. Examples: Mid-Atlantic Ridge, where Pangea broke, mice still growing. New ocean floor, East African Rift, tearing apart today, just like Pangea once did. Yellowstone, Iceland. Pacific Rim, hotspots caused by shifting tectonic boundaries formed during the breakup. Every quake in California, every blast in Iceland, is part of a much older story, one written when the Earth was still smashing tectonic plates into Pangea. Thanks to 20th and 21st century science, we've reassembled Pangea digitally. Here's how. Paleomagnetism. Magnetic minerals in ancient rocks point toward past poles, revealing crust movement. GPS and satellite tech. Today's plate movements can be tracked in centimeters per year. Radiometric dating. Dates fossils and rocks to prove simultaneous formations across modern continents. Fossil alignment. Ties together flora and fauna that could not have crossed oceans. You don't have to be a geologist to see Pangea. Wherever you are in the world, odds are, you're surrounded by rocks older than your country, You walk over ancient tectonic scars. Your mountains, rivers, or coastal cliffs were formed during or after Pangea. U.S. East Coasters. The Appalachians are older than dinosaurs. Europeans. The Alps only formed after Pangea began to rupture. Australians. Your wildlife evolved because of isolation post-Pangea. This episode isn't just about rocks, it's about connection. At one point, all ecosystems were part of one biosphere. All land animals were continental neighbors. All continents shared the same weather. Even the same water. It's a time when Earth was unified. Different, yes, but ultimately connected in a way our modern mind struggles to comprehend. The world has been one before. And it could happen again. Why do we keep talking about a land that died 175 million years ago? Because its legacy touches everything. Biology, evolution, ecosystem origin, extinction boundaries, geology, plate tectonics, earthquake zones, resource locations, climate, long-term climate prediction, ocean formation, navigation, continental drift, paleogeography, future mapping, humanity's place. It's the ultimate reminder that we, and everything we build, rest atop an ancient story still unfolding, our true, hopeful narration. The ground beneath us tells a story of fire and fusion, of journeys not yet complete. Pangea may be broken, but its legacy brings the past into today and pushes us to ask a powerful question. If the Earth united once, will it do it again? Coming up next, we fast forward to the future of Earth's continents and ask the ultimate question. Let's set the stage. You're in a futuristic time pod. The countdown reaches 0 and boom, you've landed on Pangea during the late Permian. What do you notice first? The air feels heavier, higher oxygen. The colors look different. No flowers, only greens, browns, and misty light. The sky is strangely clear, or smoky, depending on nearby volcanic activity. There's no sound of birds because birds don't exist yet, but in the distance you hear a deep buzzing. Like a swarm of something big. Welcome to Earth as it once was. Let's explore. You start off deep in the interior of Pangea, what will one day be the middle of North America or North Africa, scorching days, freezing nights, no shade for miles. What you'd see. Endless dunes, like the Sahara, but even bigger rough rock formations, shaped by wind but occasionally shattered by fault lines, sparse life, early reptiles crawling beneath rocks, avoiding the midday heat, fossil wood scattered on the ground. Dead forests long turned to stone dust devils swirl in the distance. It's silence, punctuated by the slow shuffling of creatures evolved to survive in one of the harshest biomes Earth has ever known. You're cautious. Something just moved in the distance. Could be a Scutosaurus lumbering past, a gorgonopsid predator with saber teeth glaring from the shade, a skittering dictodon, burrowing squirrel-like creature look above, a meganeura. The dinner plate-sized dragonfly buzzes past. Nearby you find an ancient burrow, and inside a leathery therapsid curled up in sleep. These aren't dinosaurs, not yet. These are their ancestors. Pangea is a land of transition, caught halfway between dominant amphibians and rising reptiles. You're not just seeing life. You're seeing evolution in motion. You hop back in your pod and time jump to what will one day become Eastern North America or Western Africa. You exit in a dense, humid landscape. Everything smells earthy, wet, and ancient rainforest features towering lycopods and gigantic ferns, early horsetailed trees as tall as offices. Steam rises as morning light pierces. Mist amphibians peer out from brackish pools. The ground is spongy with rotting vegetation, the makings of ancient coal beds found today. If you get stuck here, don't worry. You'll become part of a coal seam in a few million years. Pangea's climate isn't just hot or dry. It's chaotic. Suddenly the wind changes, clouds boil in the sky. You're about to witness a superstorm, the kind that can't exist today. Thunder you can feel through your bones, leaves spinning into sky-wide spirals. A tornado forms miles wide on the open plain. Rivers overflow instantly, turning trails to flood zones. Animals vanish. Even the trees bend away like they fear what's coming. In Pangea, weather isn't a conversation, it's a threat. Every single time, show slow-motion clips with booming cinematic drums, lightning cracking through fern forests, ash falling like snow, water surging through dry canyons. Narrator whispers, "This is Earth." Before the rules were written, you move south now to what will one day become Antarctica, Australia, and India. Now it's cooler. You've reached the ancient continent of Gondwana, but guess what? Antarctica was green, lush, forested. There are no glaciers. Just giant conifer-like trees, slow-moving reptiles warming in the ancient sun, insects crawling along roots as spores drift. This is both serene and slightly alien. Your sensors beep. It's a Glossopteris forest, a species of tree whose fossilized leaves will one day be found across 5 continents, proving Pangea existed. Hang on, we're going forward 50 million years. Now we're in the heart of the Triassic period. Pangea is starting to break, but the land is still mostly one piece. Now the stars of the show up. In the distance, heavy footsteps. You step behind a tree crashing through a fern thicket. Herrerasaurus, one of the oldest known predatory dinosaurs. Agile. Dangerous. Plateosaurus grazes nearby, unaware, a strange chirping. Early relatives of pterosaurs above, testing their wings in thermal drafts. This isn't a theme park. No fences, no walls, just raw prehistoric nature. Dangerous, hungry, and thriving. You're exploring the last unified land before modern continents. Here's your prehistoric photo album. Mud cracks and dried Permian lake beds. Footprints of a crocodile ancestor fossilizing in real time. Strange pollen floating through rays of volcanic haze. The fossil shell of a creature who just went extinct during your visit. Every picture a postcard from history. Each one a snapshot of moments lost in time. Most of those images, buried in rock today, waiting to be discovered. This world is dangerous. It's silent in ways we've never experienced. Loud in terrifying new ways. And yet it's beautiful. But more than that. Standing in Pangea, you realize something. You are not separate from this place. You're made of it. The soil beneath dinosaur. Feet became clay beneath yours. The oxygen giant. Insects breathed. Fuels your air today. The trees that shaded lizard tracks became the coal that powers our cities. Pangea isn't just the past. It's your ancestor. If you could walk this land, would you go everywhere you can today in one lifetime with no borders, no nations? What would you discover? What would discover you? Your visit is over. You step back into the machine. Silence becomes hums. Sounds collapse in. You're home. But nothing looks the same. Suddenly, that mountain range you've seen your whole life, you know it's from Pangea's collision. That fossil at the museum, a lost citizen of ancient Pangea. Every tree, descended from prehistoric survivors. You've walked with evolution, escaped extinction, watched continents collide. You were there. That's what Pangea gives us, a reminder that Earth was once whole. And maybe again, Pangea was a real place, a living, breathing world. And now that you've seen it, your own world will never look the same again. Coming next, we fast forward, not backward, for your final chapter. Section 9. Could a supercontinent form again? Let's start with a reminder. Pangea wasn't the first supercontinent. It was part of a 4.5 billion-year-old pattern called the supercontinent cycle. Every 400–600 million years, the plates that make up Earth's crust crash into each other, form a massive landmass, break apart, and start again. Earth's previous supercontinents: Columbia, 1.8 billion years ago. Rodinia, 1 billion years ago. Pannotia, 600 million years ago. Pangea, 335 or 175 million years ago. Right now, Earth is in the middle of its breakup phase. But plate tectonics hasn't stopped. In fact, the early signs of the next supercontinent are already here. Fact, some plates are still moving as fast as human fingernails grow. Turn 2 inches to 5 centimeters per year. Over millions of years, that adds up to oceans closing and new continents colliding. Let's fast forward to the year 250 million AD. Where we stand now, Earth might be halfway to its next supercontinent. Scientists have modeled 4 main theories for what this new landmass might look like. 1. Pangea Proxima, aka next Pangea. The Americas drift westward. They collide with Eurasia. Africa smashes into Europe. Australia joins Southeast Asia. The Atlantic closes. Reversing its growth, one huge continent forms, a giant C-shape crossing the equator. 2. Amasia, America and Asia merge near the North Pole. The Arctic Ocean disappears. Most land ends up in the northern hemisphere. Antarctica, isolated at the south, continues to freeze. 3. Pangea. The Pacific Ocean closes rather than the Atlantic. Asia collides with the Americas from the west. Australia moves toward India. Africa rotates slightly north. The new supercontinent forms in a twisted, equatorial shape. Most ocean now lies where the Atlantic once was. 4. Orica. All continents slowly drift toward Earth's center. A ring-shaped continent forms around the equator. Oceans fill the poles. Earth becomes a narrow tropical belt of life. Interactive viewer prompt. Which super-Earth would you want to live on? Equator-ringed Orica, frozen Amasia. The classic squished return of Pangea Proxima? Tell us in the comments. Earth 250 million AD is yours to explore. It's not guesswork. It's plate tectonic data, plus physics plus geology. Tools scientists use. Satellite GPS tracks exact drift of tectonic plates. Seismic studies detects boundaries and movement between plates. Rock strata comparison shows long-term direction of drift. Computer modeling simulates millions of years of movement under different parameters. Historical tectonic behavior. Past motion predicts future collision. Even with all that, different models predict different outcomes because volcanic eruptions, mantle plumes, and seismic rifts can change direction at any time. Let's get speculative. And if the continents merged again, the interior of the new supercontinent could become a super desert, hotter than the Sahara. Coastal regions could be battered by mega hurricanes and floods caused by ocean compression. The oceans would become more acidic, oxygen depleted and stratified, and new isolated ecosystems would evolve into weird, wonderfully alien forms if humans were still around, or something else evolved with intelligence. The biosphere could look like a totally different planet. Not likely, unless we solve aging or become post-biological spacefarers. These transformations happen so slowly. They're invisible in a human lifespan. A lifetime. Maybe 5 to 10 centimeters, a couple inches of movement in a single fault. But if we survive global warming, resource collapse and ourselves, humanity might witness the early signs over the next few thousand to million years. The East African Rift could create a new ocean. The Himalayas will grow even taller, then erode. California might drift north like a massive tectonic ferry. You may never see the next supercontinent, but you walk on the journey toward it every single day. If a supercontinent reforms, mass extinction is likely again, but after, life will flourish in new ways. Just like after Pangea broke, speculative life includes burrowing desert, reptiles in superheated interiors, amphibians, adapted to salt marsh coastal megaswamps, gigantic birds or mammals, developing in isolated biomes, intelligent species, descendants of current ones shaped by 250 million years of change. We may be the ancestors of the next caretaker species, or just a flash in Earth's memory. This series began with ancient seas and mountain collisions. What do we learn from it all? That Earth is a living, breathing system, always in motion. Continents are temporary, not permanent. Climates are cyclical. Not constant oceans are newborn. Not everlasting ecosystems will fall and new ones will take their place. Pangea teaches us that change is unstoppable, that extinction can reset life, that resilience is key to survival, and that our planet is never complete. It's becoming zooming out even further. In around 600 million to 1 billion years, the Earth's plate tectonics may slow down or stop. As the planet cools, the mantle will lose energy, plate motion may freeze. Earth could become geologically dead, like Mars, but before that, we may get one last epic supercontinent, a final masterpiece of geologic time, and we just might be the only creatures to ever understand it. In the very end, our planet may look eerily familiar. I'd all land in one place, all oceans cut off, volcanism rising again, ecosystems searching for balance. Again, the circle completes. A new Pangea is born, eliminating old species, creating new ones, until one day, it breaks again. Land rises, land falls, seas open then vanish. The Earth is writing its story, not in words, but in rock, water, heat, and life. We began with one world. We now live on 7 continents spread across vast waters. But Earth remembers, and the future is already forming beneath our feet. Pangea was lost, but maybe, just maybe, something like it will rise again. Pangea begins. One land, one Earth. It formed through endless collisions and unimaginable pressure over millions of years. A world without borders. A world not yet broken. Strange early life dotted the landscape, giant insects, sail-backed reptiles, fern forests with no flowers. An Earth halfway between water and land. Nature's rough draft. Pangea's heartbeat was violent. Megastorms swept deserts. Volcanoes erupted endlessly. Earthquakes cracked the supercontinent from within. It was not a peaceful place. It was an Earth under siege from itself. And a super landmass meant extreme climate. Dry interiors, frozen nights, hellish summers, wind without mercy. Weather was no longer local, it was legendary. Then came devastation. The Permian extinction. 90% of life perished. The Earth briefly fell silent. The closest our planet has come to complete death. Escher built. Cracks formed. The continents slowly drifted apart. Oceans appeared. Mountains shifted. The modern world began. It didn't break in a day. It tore endlessly, reshaping destiny. The fingerprints of Pangea are still everywhere. In our mountains, fossils, oceans, and even the rocks beneath your feet. To understand your world, look deeper into its past. We traveled together, walked ancient deserts, hid from giants, sailed swamps, touched the raw edge of evolution. You didn't just learn about Pangea, you lived it. Yes. One day the continents will crash back together. A new Pangea will rise. The cycle will continue. Everything ends, then begins again. Pangea isn't just about Earth's past. It's about its spirit of change. Continents smash, separate, then circle back. Life dies, returns, rebuilds stronger. Earth tears itself apart to grow again. It's a cycle older than memory. Bigger than language, and it continues beneath your feet right now. If this series taught you something new, if it left you in awe, then hit like, share this with someone who loves Earth science, and subscribe for more deep dives into the planet's untold stories. History isn't just castles and kings. It's continents, creatures, chaos, and calm. It's our story, and it deserves to be told, because whether we survive, thrive, or vanish, Earth will continue to move and become something new. Post-credits ideas like in Marvel-style outros. What would life look like on the next supercontinent? How would humans build civilizations on Orica or Amasia? What if we found fossils of ourselves one day? Series wrap-up, playlist tips, add links. Start from episode 1 here. Create topics like Pangea in 60 seconds, FAQ shorts encourage. Teachers, educators to use full series in classrooms. Label educational content. End with a poetic reminder of Earth's grand story. Long ago we were one. One land, one breath, one storm, One silence, then earth shattered, rebuilt, broke again. But each time, it remembered the past isn't dead. It's alive in stone, in stars, and in the dust beneath your feet. Cue ambient music fading into soft earth rumbling sounds. Continents slowly shifting in the background.